let's say there's 4 timescales of weather prediction. There's what's called kind of nowcasting, which is kind of 0 to 6
Yeah.
even hours. So very short term. And then there's kind of the 6 to 12 up to say 5 or 6 days short term, medium range,
Yeah.
5 to 6 to 15, and then subseasonal beyond that. Right now, with the current state of things, AI, in my opinion, is sort of best suited for that long range, like we talked about, the 15 to 45 days,
Yeah.
and that nowcasting phase. So the
Right.
0 to 6 hours, it's very hard to gather all the data, spin up your physical models, and have them produce rapid forecasts. And Google's actually done a lot of great work on this, where they've just taken years of radar data. They call it the MetNet model, and they've trained it. They just predict the next radar frame, and that kind of informs you where precipitation is going to be moving in the future. And the model actually learns to kind of dissipate and grow individual precipitation kind of convective cells, which is really fascinating. Before, typical nowcasting models will just use what's called kind of an optical flow method. Getting a little technical here, but that's just where you kind of advect the cells forward in time. So there's been a lot of promise on that extremely short range. And you can imagine creating a very strong cloud forecast where you're using sort of visible satellite data all around the globe, so you know where clouds are at very high resolution, and then predicting the next frame of where that's going to be. So it's sort of a video prediction problem, which is largely been solved in the AI community, but you can apply that to weather data. So you can apply that video prediction model to either radar data or any sort of spatial satellite data set. And I've seen some very promising research where using, for example, diffusion models, which are commonly used for video prediction, you can predict the next frame of a satellite image and know where clouds are going to go and where they're going to form. And because they're so cheap, you can run them, say, every 10 minutes. So you're just getting this rapidly updating model that provides really reliable information that simply cannot be done with the physical model. But yeah, and like you said, in the short term range, which we kind of call the 6 to 12 hours out to 5 to 6 days, that's where resolving the true physics of the atmosphere at very high resolution, it's very hard to beat that with AI. And a lot of that has to do with, we just don't have strong 3-dimensional analyses that know the historical weather going back 50 years to actually train these models. There's been some promising work kind of taking a global forecast and downscaling it to 3 kilometers, but you're missing a lot of information there about how the small scale weather actually influences the larger scale, because they're just downscaling. You're just going from large scale to high scale to small scale, sorry. So if the global model missed the placement of an individual low pressure system, it's still going to be in that place. The high resolution data is not going to be able to impact it.